Alright, let's go through factorizing polynomials to find zeros, otherwise known as finding solutions to polynomials. Alright, so let's go through this question. So here we're asked to solve for x, given x minus 1 times x plus 2 times x plus 5 is equal to 0. Now, to solve this one, right, one of these just has to be equal to 0. Because, like, 0 times anything, right? So 0 times anything is just 0. And so if one of these are 0, then I've solved the solution. Maybe this will make more sense once I solve it. So as I mentioned before, one of these has to be equal to 0. So the equations I'm solving are this. The first one has to be equal to 0. The second one has to be equal to 0. And the third one has to be equal to 0. So 3 separate equations. Oops. Okay. Now this is really easy to solve. You just have to bring the numbers over. So this is x equals to 1, x equals to minus 2, and x equals to minus 5. And so these are my solutions. And just to show how these are the solutions, right? Let's say I sub in 1 into this whole equation. So 1 minus 1, 1 plus 2, 1 plus 5. So this is equal to 0 times 3 times 6. And this is obviously equal to 0. And so that's why either one of these three have to be equal to 0. Okay. This part of the video won't make sense unless you've seen the remainder and factor theorem, as well as polynomial long division. So if you haven't, I have videos on that. You can just check those out. All right, so let's do this question. Solve x cubed plus 2x squared minus 5x minus 6 is equal to 0. Now, I'll be going through the first step. So the first step says to find one factor using remainder and factor theorems. What you really need to do, right, is you need to find a factor. And from factor theorem, right, I know that if p of a is equal to 0, then x minus a is a factor. And so how do we find this x minus a to sub into this polynomial? So what you need to consider, right, is the constant term. And you need to figure out what are the factors of minus 6. And so I know that the factors of minus 6, are, there's minus 1, 1, 2, minus 2, minus 3, 3, 6, minus 6. Okay. And this kind of uses guess and check. So there's no really like good way to figure out which one's going to be the factor. So usually you would start at the beginning. So you would start at like minus 1 or 1, and then move up to 2 and minus 2 if these aren't the solution, and so on and so on. You just keep moving up. And so with that being said, I want to check if x minus 1 is a factor. So I want to check for p of 1. And so p of negative 1 is equal to minus 1 cubed plus 2 minus 1 squared minus 5 minus 1 minus 6. And this is equal to negative 1 plus 2 minus 5, plus 5 minus 6. And this is equal to 0. So x plus 1 is a factor. Okay? All right, and since I know that x plus 1 is a factor, right, I can do the second part. So I'll be using long division to find the quotient after dividing the factor, which is x plus 1. So let's do some long division. X cubed plus 2x squared, 5x minus 6. All right, so here you want to divide x cubed with x, so that's just x squared, times x squared with these two, so minus x squared plus x squared. This will give you, sorry, that should be x cubed. This will give you x squared minus 5x 6. And then rinse and repeat. So x squared divided by x, that is just x, times x with these two, so x squared plus x minus them, you will get minus 6x minus 6. And then divide minus 6x with x, that is just minus 6, times minus 6 with these two. So minus 6x 6. And you should get a remainder of 0. Whoops. All right, so now we found the quotient, right? Which is this thing right here. So this is the quotient. And the third part says factorize the quotient if possible. Okay? So, x squared plus x minus 6. So we're going to factorize this. And I know that if I use PSF, right? So product sum factor. Product is minus 6. Sum is 1. And the factors will be minus 2 and 3. So this will be equal to x minus 2, x plus 3. So I can express polynomials in this form, where a of x is the divisor. And the divisor in this case is x plus 1, which is what we use to divide the original polynomial. Q of x is the quotient, which we found here. And r of x is the remainder, which we found from before was 0. Okay, so this polynomial right here, so I'll write it again. Q of x is equal to x cubed plus 2x squared minus 5x minus 6. So this can be expressed in terms of this, x plus 1, x squared plus x minus 6. Okay, now we know that, so we've already factorized this as well, right here. And so this can also be broken down into x plus 1, x minus 2, x plus 3. All right, we're almost there. So remember, this question asks us to solve this, okay? So this has to be equal to 0. So we need to solve for p of x is equal to 0. In other words, x plus 1, x minus 2, x plus 3 is equal to 0. All right, and from the first question that we did, this is where it becomes useful. So I'm not going to write the whole entire working out, but the solution is this. X equals to 2, x equals to minus 3. And that is the final solution. Just another thing, right? This fourth step was this thing right here. Okay. And yeah, I know that was a long process, but it gets easier once you practice like a lot of these. Okay. You get used to it pretty much.